you know that to the relation between the uh, an eigenvalue and the eigenvector corresponding to this. And for that we use this relation PV, where V is an eigenvector and this is equals to lambda V, where lambda is an eigenvalue. And here you observe that imposing P, you see here P, this P has been imposed on this vector V, and by doing so you get a vector parallel to this vector V. Okay, so this is the relation between an eigenvalue and its corresponding vector. And the same equation can be rewritten as, I show you this way. You can write this way: P minus lambda I. Here I is an identity matrix of size 3, and here this will be V equals to 0. Now let suppose P you see in the question is 3 into 3 matrix, so we can assume it to be A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. Now now here you see the first eigenvalue is 0 and its corresponding vector is this one. So here if I type subscript 1, then here will be, you have to write 1. Okay, now put the values in this equation. If you do that, then this will be here will be A11, A12, A13, A21, A22, A23, A31, A32, A33 into V1, and V1 in the question you see in red underlined, it is 1 0 0, and this equals to 0. And from this, and remember that this 0 is not the integer 0. This 0 means the null matrix, this matrix, the 0 matrix. Okay, so be careful. Okay, so accordingly here it will be, sorry, it will be 0 0 0 0 0 0 0 0 0. Okay, now if you compare, then we have A11 equals to 0, A21 equals to 0, A31 equals to 0. So using first eigenvalue and eigenvector, we got these things. Okay, so accordingly I here make the change. Here I change. Okay, here will be in the first column, it will be 0 0 0, and here it was A12, A22, A32. Okay, now we go for the second eigenvalue and eigenvector. For that I now erase this thing. Okay, Now I have to use the second, so here will be this time 2 and accordingly here will be 2. Okay, so now putting the values, we have this time here will be -1, a1 2, a1 3. Here will be 0, here will be a2 2 -1, here will be a2 3, here will be 0, a3 2, and here will be a3 3 -1. And v2, you see, you observe that lambda 2 is 1 and v2 is this matrix, this column matrix, and that is 1 1 0 this time, and this will be equals to this matrix, this null matrix. Okay, so now again compare the same, and this time here comparing, we have -1 plus a12 equals to 0, and second will be a22 -1 equals to 0, and the third will be a32 equals to 0. And so we can type here a12 equals to 1, a22 equals to 1. So this time we have two more values, and so I accordingly here erase these two, and at this place I can type a12 is our 1, and here you see a22 is 1. So by doing these things we are getting numerical values instead of expressions. Okay, so I now erase these things, these things. Okay, I have erased. Now the time comes to go for this value lambda 3, and here is v3. So here if you write 3, then here will be 3. Okay, so now putting the values, we have here will be 1 1 a13, and thereafter 0 2 a23, and here it will be 0 a32, and here will be a33 plus 1. Okay, and v3, here will be v3 is our 1 0 1, and this equals to 0 0 0 0 0 0, the null matrix. Okay, now let us, since this is the final putting, so we should see the question, and here you see the entry in the first row and the third column of P, first row and the third column, and that entry is this one. Okay, this one a13. We have to find the value of this a13. Now if you multiply the first row with this column vector v3, then we have 1 plus a13 equals to 0, and from here we have a13 equals to -1. So our correct answer is -1. So you see -1 in option C. So option C is our correct option. Now this question is over.